I'm Rachel Farrell. My co-authors are Mira Fisher and Stephen Ware, and our poster is now titled Salience Vectors for Measuring Distance Between Stories. So the problem that we're addressing with this is that narrative planning produces many unique solutions. And the stories in the solution space are really similar to each other, and they only differ in like minute little ways. It becomes difficult to measure how different they are. And this is because syntax differences are not the same as semantic differences. So two stories may have a small little syntactic change that could lead to a very different seeming story. Likewise, stories may not be very similar syntactically at all and still feel very similar to the user or to the reader of the story in any way. So what we want to do is find a story similarity metric that measures what's meaningfully similar or different about stories according to humans. And there are a number of use cases that I want to mention. For one, experience managers often need to reason about trajectories through an ongoing story. They might want to compare different trajectories, perhaps because they're trying to railroad the player to a story that's sufficiently similar to some predefined story. On the other hand, they might want to present the player with options that lead to substantially different stories, as well as anything else that you can imagine. Another possible example is solution diversity is a measurement of how diverse a solution set is overall, which is often used to evaluate either a planning domain or planning models. There are planning algorithms that specifically aim to produce solution sets that are diverse. And in order to measure this, we need some sort of distance metric that measures the distance between stories. And usually syntax-only methods are used for this. So I'm proposing that these measurements would be better if they were based on human perception. They would be more accurate because they would be reflecting what humans find to be different about stories. And finally, my personal motivation is domain authoring tools. Authoring narrative planning domains is super hard. And one of the many reasons why it's hard is that these solution spaces are so big, it's like impossible to communicate to the domain author what types of stories exist within this solution space. So my goal with this is to be able to cluster a solution space using this metric and present the domain author with like a breakdown of the possible types of stories, which means I not only need to measure distance between stories, I also need to be able to summarize the clusters. So I need to have information that points to why certain stories are similar and what makes that cluster different from the other clusters. So the approach begins with the event indexing model of story comprehension, which describes how when humans perceive stories, we segment information into discrete events that are connected based on common entities that they share. So for example, an event might be connected to another event because it involves the same characters or because it takes place in the same location and so forth. So we track 5 different dimensions: who, where, when, why, and how. So what I produce with this algorithm is a vector for each story that represents the salience of each story entity at the end of the story. What I mean is an entity is like a character or a location, or it gets a little complicated, so come talk to me at the poster about what the other entities are. But each entity in the story can be some amount of salient at the end based on how recently that entity was used. So we're basically summarizing a story as like a snapshot of the reader's memory right at the end. And then we can simply compare stories using vector distance functions by comparing these story vectors. So as a visual example, these are 2 story vectors. Each vector is broken down into 5 components, one for each of those dimensions. And these are the possible entities that could be in the story. So these are from the same domain. There are 2 characters, 4 locations, 2 time frames, and so on. And then the values in the vector represent how salient that entity is at the end of that story. So this story ends with that character and that location. It used that slightly more gray location, but it didn't use it right at the end. And you can see more information about that. And then we can do that for another story, and now we can compare the similarities in each of these components between these 2 stories. We can see like this character ended this story, so it's probably not a good story for the protagonist if the antagonist acts last. They involve some of the same locations, but they have the same, they end in different locations. That one's supposed to be a little bit blacker, you can't really see it, but They have the same time dimension. Anyway, you can see like where these differences and similarities are. So this information is captured in the vector, and I can use that in my future work, summarizing the clusters of the breakdown of the solution space. And of course, this gives us a numeric distance metric that we can use simply to measure distance, which is the point of this poster. And so we evaluated that distance metric by comparing it to human assessments of story similarity. Our data set is there. And we compared it to several other distance metrics. Some of them are planned distance metrics that are syntax only, and ISIF distance, which takes into account some story semantics, and then some linguistic methods, including BLUE and Rouge, and one that is based on BERT. And our results are pretty good, so come talk to me at the poster.